I'm Clint Sharp, co-founder and CEO of Cribble. Today, I'd like to tell you a little bit about our company and our product. To start with, let me tell you a little bit about how the company started. The company was founded by three ex-Splunk employees. We left in 2017, and we went out not initially searching for this particular problem, but what we ended up finding as we got out into the marketplace was that customers were continuing to struggle with the overwhelming volumes of log data being thrown at them. And the primary limiting dimension for their ability to secure and operate their enterprises was being driven by the cost of aggregating and storing potentially massive volumes of log data. And that problem is still true today. Global data is growing at a 25% compound growth rate. And what that means is by 2025, enterprises are going to have 2.5 times more data than they do today. And anecdotally, I was at Splunk for more than 5 years. And during my early tenure there, I worked in marketing, and I can remember a number of reference customers that Splunk had at their disposal. And I remember being very blown away by data volumes in 2012 that were measured in the tens to hundreds of terabytes of data per day. And now those exact same enterprises are delivering the small ones tens of terabytes. The average customer that Cribble engages with is moving single digit terabytes a day, at least, if not into the tens of terabytes of data per day. And the largest of our prospects are in the tens to low hundreds of petabytes of data that they may move per day. And we have many customers in the tens to hundreds of terabytes of data per day. All of this data movement has created a massive problem with capacity in logging systems. And nearly every customer that I end up talking to is already at the red line when it comes to how much more capacity they have available to them. And it's not as if they don't have a desire for more. They certainly feel like the systems that they have available to them are generally solving the problem of being able to find a needle in a haystack, to do a security investigation, to trend performance over time. The original use cases that they pressed their logging systems into service for are certainly doing those jobs, but they also have many, many more terabytes of data that they're looking for. And in fact, anecdotally, I tend to ask nearly every customer that I come across, how much more data is there? If you could, without, cost as a factor, onboard as much data as you would like, how much more data would there be? And universally, the answer comes back at least 5 times more data. So if they're ingesting a terabyte of data per day into their logging tool, they wish they could have 5 terabytes a day. And this is where the costs are already in the millions of dollars. So in our larger prospects, customers are spending tens of millions of dollars per year just in infrastructure alone to run their logging tools. And the median customer is in the millions. And with that, the retention is really only measured in months today, with the desire that they wish that they had years of retention. If you look at a modern breach investigation, you don't really know how long that attacker has been on the inside. And so realistically, you would like to be able to reconstruct even full fidelity flow information, endpoint logs, everything about what was happening at the time when you first have detected that attacker's first intrusion, and really be able to navigate that data all the way up to the present day. But in today's architectures, we're really only able to maintain high fidelity data for some number of weeks at best, but definitely not the years that we really would like to. And another thing that we hear is certainly licensing is expensive in the logging ecosystem. Nobody would say that this software is cheap, But really, infrastructure costs are actually the primary driver of cost in this ecosystem. And for every dollar that someone's spending on software licensing, they're spending $2 on infrastructure. Or if they're in a SaaS type offering, this is all being rolled up together, further driving the perception of logging systems as being expensive. And data management techniques are evolving as a result of this cost dynamic. So there's a number of new ways of managing data in this ecosystem. On the IT side of the world, we see the advent of time series databases. Time series databases allow us to store millions of unique time series very, very cost effectively, often on a few servers, where storing that full fidelity information as logs might take 5 or 10 times the amount of resources. We also see the advent of data lakes. And so people are throwing terabytes and terabytes of data into S3 or into Hadoop and leaving it there unstructured. And then thirdly, we're also seeing the advent of cloud data warehouses like a Snowflake or potentially a Databricks or maybe an Amazon Redshift. But with all of these, we see a number of different problems. Distinctly, cloud data warehouses and time series databases are schema on write systems. So they fundamentally require significantly more planning and preparation in order to get the data into the right shape required in order to be usable in a time series database or a cloud data warehouse. Data lakes offer very, very cost effective storage, and they allow you to optionally store data in a schema on read fashion so that you don't have to do the prep work in advance. But there simply aren't very many tools for making use of log type of data in data lakes. Most data lake technologies like Presto or Amazon Athena really depend upon that data being incredibly well structured, perhaps JSON documents or Parquet or org files that you can query or analyze. And so we don't see any of these particular technologies being usable out of the box with the existing ingestion pipelines that you already have at your disposal. So each one of these technologies is going to require a new agent deployed out at the endpoint for data collection. They're going to require some type of data prep work or ETL work that's going to be required in order to make log data usable inside any of these data stores. And that's really where Cribble Logstream comes in. So Cribble Logstream is a streams processing engine purpose-built for log and metric data. We don't focus on general purpose streams analytics. We've really built a fit for purpose solution targeted at security professionals, at IT professionals, to help them solve a number of problems in their day-to-day life. The first is that Cribble Logstream allows you to route data to multiple destinations. So we can take your existing deployed footprint of agents and allow you to collect that data and then send it to its original destination simply as a bump in the wire. So for example, we can take data from a Splunk universal forwarder and deliver it to a Splunk indexer. And in the Splunk indexer, it looks exactly the same as if Cribble had never been there. And to the producer, it looks exactly like a Splunk indexer. And so we can transparently insert ourselves inside of existing ingestion pipelines. And then we can also route that data to multiple destinations. And so usually use case number one is being able to tee the data off and send it to a second destination. Most popular second destination are object stores like Amazon S3, or perhaps an event streaming tool like an Apache Kafka to deliver data to a data lake. And so we can easily take and connect things that were not originally intended to be connected. Think of it like a universal adapter for log data, being able to take data from anywhere and deliver it to anywhere. Second, often paired with creating that online archive by delivering data to cheap storage in S3, is also reducing log data in more expensive analytics tools to free up capacity for other use cases. And so canonical examples of reducing this data are Take, for example, something like a Cisco eStreamer format, which has dozens of key value pairs, usually in the 90s in terms of number of total key value pairs. But many of these key value pairs are actually set to null or NA, meaning literally they have no value. So you're ingesting key equals null over and over again, chewing through storage capacity, chewing through licensing capacity. And so Cribble Logstream allows you to easily filter out whole events. We can say, I want to drop this series of events. We can do things like sample that data and keep one out of every n events. We can transform single events to remove unused fields so that when they're delivered to the more expensive destination, you're freeing up capacity for other use cases. And then lastly, this is also paired with our replay technology, which allows you to take data that you've routed to cheap storage and then bring a subset of that data back to the front of the stream for further processing in other systems. And so with replay, you never have to worry about whether you've removed something that is super critical. If you filter data out to the expensive index storage, you have your full fidelity copy available in object storage, which is available at any time. So we can come back at any point in time and run a job and collect data. And that job can be filtered to certain time ranges, to certain hosts, or to certain types of data. And so since you can collect back from cheap storage, you can, with confidence, make any type of filtering decision you may want in advance. So when we look at what a real security pipeline looks like, it has a number of properties. The first is that it's a universal receiver. And so that means we can collect data from your traditional shipper agents like a Splunk Universal Forwarder or Elastic's Beats agent. We can collect data from network devices, perhaps emitted over syslog. We can collect data from applications. We can collect data from metric agents. We can collect data from your SIM tools or from your UEBA tools. And we can receive that data as it's being sent to us and process that data through our series of routes and pipelines. In addition, we're also a universal collector of this data. So that means that we can reach back out and run jobs to collect data from a data lake. We can collect data from an event streaming system like a Kafka. We can collect data from your existing analytics tools. We can collect data from your network devices or from REST APIs. And we can do that on an ad hoc basis or on a scheduled basis to bring data all into our pipeline where we can then connect any of these sources to any of these destinations. And that means connecting things which may not have originally been intended to be connected, like connecting a big data shipper to a time series database, for example. We can connect any source to any destination. And this also allows us to fundamentally separate our system of analysis from our system of record. Log analytics tools, while they're great for finding needles in haystacks very, very fast, they make for very expensive systems of record, as we'll get into here in a few slides. And lastly, our pipeline allows us to fundamentally eliminate noisy data and be able to get rid of events that are uninteresting or fields that are uninteresting. So let's talk for a few minutes about kind of why it's so expensive to store data in traditional log analytics tools versus putting data into something cheaper like an S3 or a data lake. When we bring data into an index log analytics tool, the first thing we do is we compress the raw data. So that generally compresses at about 10 to 1. So we can assume if we're bringing in a gigabyte of raw data, we're going to store about 100 megabytes of compressed data. And then we index that data so that we can find needles in a haystack very, very quickly. The index is usually about 3 times the size of the compressed raw. So now we're storing about 400 megabytes of that original gigabyte on disk. But because log analytics tools are also distributed systems in their own right, if we lose one of our nodes, we don't want to lose our only copy of that data. So we replicate the data 2 more times. And by the time we're looking at the total cost of our log analytics tool, we're actually storing 1.2 bytes of index data redundantly across 3 different systems for every 1 byte of raw data that we brought into the system. And on top of that, we're storing that data in expensive block storage. So in order to scan around and find needles in haystacks, we need to be able to jump around inside of files, and we need to be able to have the data that's being stored in our log analytics tool in block, fast block storage that's attached to the compute that we're using to query it. Versus in our archive or storing data in our data lake, we can have that separate in object storage in a much more cost-effective manner. So if you look at the cost of object storage, S3 infrequent access is going to cost you about a penny and a quarter a gigabyte a month. And so to store a terabyte of compressed raw data in S3 infrequent access is going to cost me about $12.50 a month. Now, just taking that same compressed data and putting it in block storage is going to cost me 8 times more, so $100 a month. Now we need to index that compressed raw data, so we're going to add another 300% on top, which is going to make it $400 to have a single copy of that. But then, because we need redundancy, we're going to replicate the data another 3 times, meaning that we're actually storing or paying $1,200 to store the exact same data in an indexed log analytics store versus storing this data cheaply in S3 infrequent access. And so with this type of economics, we're now opening up an ability to have a fully featured, full fidelity copy of all of the data inside the enterprise. So from a security perspective, if we've ever wanted to go back in time and be able to understand what was happening at that exact point in time, this is now available to us from a cost perspective, because for the first time, Cribble Logstream is making that archive accessible to your average log analytics administrator, so that we can easily go suck out the data that may be relevant and deliver that to a Splunk or to an Elasticsearch at a much later time. And really what this is allowing us to do is to fundamentally defer the decision about the value of the data until a much later time. And so really what that's allowing us to do is process our data before we're paying to analyze it. And so as data is coming through Logstream, administrators configure Logstream to help you determine whether this data is something that we want to analyze now. Should I send it to my indexed data storage? Should I send it to my time series database? Some of that log data may actually be metric data. So a great example is a web access log is really the number of bytes sent and time taken with a number of dimensions describing that. What URI, what user agent, what IP address did this traffic come from? So we may prefer to express that data as metrics where we can store it much more cost effectively in a time series database. We may want to be taking some of this log data and stashing it in a cheap object store just in case we end up needing it later. Or some of this data may not be interesting at all, in which case then the right answer might be just to drop that data as it's moving through the pipeline. Additionally, with our replay feature or data collection feature, we now have brought batch processing to log systems. And so our data collection feature allows you to potentially massively reduce the amount of data that you're sending to a log analytics tool, because now you know inside of this bucket is the full fidelity copy that you may need to go back to for later investigations. It also allows you to fundamentally retain data for a significantly shorter period of time. So if we know we always have this archive to go back to, rather than maintaining data online in Splunk or Elasticsearch or another index log analytics tool, we can drop the retention on those tools down to a few days or a few weeks at most, knowing that we have a cost-effective archive we can easily come back to later. And this also allows us to fundamentally change how we think about log systems. So with the advent of easy to use cloud log analytics tools, we can stand up a Elasticsearch cluster, or we can spin up a new Splunk cloud account and run a stack simply for the purpose of that investigation. So if we know we have an investigation that's going to require large amounts of data, we can go suck that out of the online archive, out of our S3 bucket, and deliver it to the system, which may be used only for the duration of a single investigation. So Cribble as a company, we're about 3 years old. we have a number of phenomenal customers from Autodesk to Shutterfly to NASA JPL and many more whose logos, unfortunately, I can't name, who are getting value out of our product on an everyday basis. And even if you don't consider our product, I would strongly recommend you to go take a look at modern pipelining techniques and the type of optimization you can get inside of your log analytics pipeline in order to deliver significantly more value to the business for your security investigations at a fraction of the cost that you're doing today. And with that, I thank you so much for coming to our presentation.